Dora!
Wow!
And today, we're going on a math adventure. Can you say rationalizing the denominator? Say it with me. Rationalizing the denominator. Great! Do you know what that means? Me neither. Just kidding. Let's explore it together. But first, who do we need to help us? Backpack! Backpack!
Backpack, 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 backpack. On the backpack loaded up with things and knickknacks too. Anything that you might need, I got inside for you. Backpack, 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 yeah!
Backpack, 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 backpack. Inside me today, I have a square root, a fraction, and a magical math one. This will help Dora rationalize denominators.
Thanks, Backpack. Now, let's start our math mission.
If there's a place you gotta go, I'm the one you need to know. I'm the map. I'm the
I'm the map! To understand rationalizing the denominator, you need to follow these 3 steps. First, you need to know the topic. Second, we need to learn the rules. Then third, solve 6 examples.
So, what is rationalizing the denominator? It means making the denominator the bottom of a fraction free of radicals, like square root of 2, square root of 5, square root of 7. Fractions like 1 over square root of 2 or 3 over square root of 5 are not considered simplified in math. We do this because it is easier to work with and it is nicer to work with. Why do we do it? It makes answers simpler, it makes expressions easier to compare, and it follows math rules for simplified forms.
To rationalize the denominator, we have to follow these simple rules. One is to multiply the denominator by something that removes the radical. Like square root of a, which is single root, you have to multiply by square root of a. For example, 1 over square root of 3, you multiply the top and bottom by square root of 3. Now for binomial denominators, like a plus square root of b or a minus square root of b, you have to use the conjugate. So the conjugate of a plus square root of b is a minus square root of b. And the conjugate of a minus square root of b is a plus square root of b. Now for rule number 2, whenever you multiply in the bottom, you must multiply in the top so that the value does not change. Now, let's practice these simple and easy steps. Steps for rationalizing single radical denominators. 1, you have to look at the denominator. 2, you identify the radical. 3, you multiply top and bottom by the same radical. And for 4, you just have to simplify. Now, the steps for binomial denominators. 1, you look at the denominator, which is a plus square root of b or a minus square root of b. 2, you multiply the top and bottom by the conjugate. And 3, you use FOIL to multiply. And of course, you can't forget one of the most important parts, which is to simplify. So, when do we have to rationalize? We rationalize when 1, the denominator has a square root, or when 2, the denominator has a radical expression. 3, when the denominator is a binomial with radicals.
The first example is 1 over square root of 2. We need to multiply its numerator and denominator by the square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is equals to 4, and the square root of 4 is 2. So the final answer is square root of 2 over 2. The second example is 5 over square root of 3. First, we need to multiply the numerator and denominator by square root of 3. 5 times square root of 3 is 5 square root of 3. Square root of 3 times square root of 3 is equals to square root of 9, which is 3. The final answer is 5 square root of 3 over 3. Our third example is 7 over square root of 6. First, we need to multiply the numerator and denominator by the square root of 6. 7 times square root of 6 is 7 square roots of 6. Square root of 6 times square root of 6 is equals to square root of 36, which is 6. The final answer is 7 square root of 6 over 6. For our fourth example, we will be using the conjugate. 1 over 2 plus square root of 3. First, we need to find the conjugate of the denominator. Our denominator is 2 plus square root of 3, so our conjugate is 2 minus square root of 3. Now we need to multiply the numerator and denominator by the conjugate. Using the distributive method, 1 times 2 minus square root of 3 is equals to 2 minus square root of 3. For the denominator, we apply difference of squares. 2 squared minus square root of 3 squared is equals to 4 minus 3 or 1. So our final answer is 2 minus square root of 3. Our fifth example is 5 over cube root of 4. First, we need to find a number that if we multiply to 4, it will result into a perfect cube root. That number would be 16. Next, we multiply the numerator and the denominator by that factor. 5 times cube root of 16 is equals to 5 cube root of 16. Cube root of 4 times cube root of 16 is equals to cube root of 64, which is 4. So the final answer is 5 cube root of 16 over 4. Our sixth example is 1 over cube root of 3. First, we need to find a number that if we multiply it to 3, it will result to a perfect cube. And that number would be 9. Next, we will multiply our numerator and denominator by 9. 1 times cube root of 9 is equals to cube root of 9. Cube root of 3 times cube root of 9 is equals to cube root of 27, which is 3. So the final answer is cube root of 9 over 3.
Hey, we did it! We finally completed our math mission. So, what did we learn today? We learned what rationalizing the denominator means, why we do it, the parts and rules, the easy steps, and last but not least, the 6 examples that we just solved. You're amazing, Explorer. Hasta luego. Goodbye.